Our learning objective for today, students will graph quadratic equations in standard form and intercept form. So to begin our lesson, let's review some older concepts of factoring. Okay, so problem number 1, which of the following cannot be factored? Okay, so let's take a look at A. We should be able to recognize that, hey, this is x times x, this is 8 times 8. It looks like a difference of squares, but this plus sign tells us otherwise. So this means that is prime. A is one of our answers. It cannot be factored. Okay. Now let's go ahead and check part B. Okay. Now to check to see if this is factorable, we just need to make our diamond. So negative 64 goes on top, negative 16 goes on the bottom. If we cannot solve this diamond, then it is not factorable. If we can solve this diamond, then it is factorable. Well, we want two numbers that multiply to give us negative 64, that add to get negative 16. Well, off the top of my mind, I'm going to say negative 8, positive 8. Well, negative 8 times 8 is negative 64, but negative 8 plus 8 is not negative 16. Well, let me change some signs around. Let's go positive. Well, 8 times 8 is not negative 64, so that doesn't work. So there are no possible answers for this diamond, which means B is also not factorable. Okay, now let's take a look at C. Okay, so again, same idea. If we can make the diamond for this, then it is factorable. If we can't, then it's not factorable. So negative 64 goes on top, negative 30 goes on the bottom. So what two numbers multiply to give us negative 64 that add to get negative 30? Well, that's going to be negative 32 and positive 2. So C is factorable. It is not one of our answers. Okay, we don't even need to factor it down. As long as you can solve the diamond, you should know that it is factorable. Okay, now let's go ahead and take a look at D. Okay, so again, we're going to set up our diamond. Two numbers that multiply to give us negative 64 that add to get negative 34. Okay, again, maybe we'll try something similar, negative 32, positive 2, but we already know these are the answers for this diamond. So these numbers possibly cannot work for this. So maybe let's change some signs around. 32 times 2 is not negative 64, so that doesn't work. Maybe we put the negative on the 2. So we have 32 times negative 2 is negative 64. Okay, good. But what about negative 2 plus 32? That is not negative 34. So guess what? This is not factorable. So D is also one of our answers. Okay, now let's check out part E, or letter E. Well, again, we know this is x times x, this is 8 times 8, and this time this is a difference of squares, so we can factor this. I'm not asking you to factor, I just want to know, is it factorable or not? In this case, it is, and we want the ones that cannot be factored. So for number 1, the answers are A, B, and D. Okay. All right, now let's go ahead and take a look at problem 2A, some more factoring review. Okay, so problem 2A, we are asked to factor this trinomial 2k squared minus 8k minus 90. Now let's recall, whenever we are factoring, the first thing we always want to be on the lookout for is a GCF. So can we factor out a GCF between 2, 8, and 90? Yes, we can. We can factor out a 2, so then that gives us k squared minus 4k minus 45. Okay, now we can factor this trinomial. We set up our diamond. We want two numbers that multiply to give us negative 45, that add to get negative 4. The numbers that work here are going to be negative 9 and positive 5. So recall, from this step, we're going to split up our middle term here. Okay, don't forget the variable. On the left side, we're going to put minus 9k. On the right side, we're going to put 5k. Bring down the minus 45, bring down the k squared. Now we factor ladder each side. Factor out a k, we get k minus 9. Whatever we factor out on the right side, we should still get k minus 9. So on the right, we're going to factor out a 5. We get k minus 9. Now grouping our answer together, we get k and 5, so that gives us k plus 5. And then our remaining two pieces give us that k minus 9. But now, let's not forget our GCF from the very beginning, this 2. That also needs to come down. So our final factorization of this is 2 times k plus 5 times k minus 9. Okay, so that was problem 2A. Now, problem B of this, or part B of this problem, says write a surge response. Write a SIR response explaining your process to factoring 2k squared minus 8k minus 90. Now, let's review SIR really quick, okay? Here is what SIR is. C stands for claim, E is for evidence, R is for reasoning. Okay, so let's kind of go over a quick example on how to do or write a SIR response. Okay, so generally speaking, we're going to start off with C, obviously, which is our claim. So answer the question using a statement, I claim. Okay, so we're going to go ahead and do that. Okay, so I'm going to try something new here. I've never done this before. I'm going to type on Notability and see how that works out for me. Okay, so we're going to start off with the statement, I claim, okay, that, and then I don't know how to do numbers on here, so I'm going to handwrite that 2k squared minus 8k minus 90 factors to, whoops, I didn't want that F uppercase, so let's do lowercase. Factors to, and we'll go ahead and handwrite, oops, 2 times k plus 5 times k minus 9. And we'll put a period. So this might take a while, so just bear with me. Okay. And then, you know what? Let me change the color to color code thing. So since C is in blue, I will go ahead and try to do all of this in blue. So let me select, do blue. All right. Then let me change this to blue. There we go. Perfect. Just like that. Okay. So that's going to be our claim. Okay. So now we're going to continue on. Oops. And then now so that's our claim. So that takes care of the E. Now we're going to do, the C. Now we're going to do the evidence part. So my evidence is, so maybe I will do that in pink, the same color to color coordinate things. So let's go ahead and do that. So now we're going to say, my evidence is that we can first factor out a GCF. Whoa, okay, so let me pause it. Let me try to get that looking good for us here. Okay. Bear with me, guys. This is going to take a while. Okay. My evidence is that we can factor, nope, I want to do this in pink. Factor out a GCF. Okay, why is it capitalizing the F? All right, that's fine. We'll just leave it. That we can factor out a GCF of 2. Leaving us with, and I will handwrite this, k squared minus 4k minus 45. Or actually leaving us with this. 2 times k squared minus 4k minus 45. And we'll put a period there. And then the next thing we can do and then we'll say, then we can set up a diamond then we can set up, oops, sorry guys, just bear with me here. You can set up and solve a diamond for negative 45 on top and negative 4 on the bottom, which works out to be negative 9 negative 9 and 5. Now we can factor k squared minus 4k minus 45. To be k minus 9, oops, k minus 9 times k plus 5. Okay, then we put our GCF of, oops, GCF of 2 in front, giving us two times k minus 9 times k plus 5. Okay, so now that takes care of the the evidence part, okay, my evidence, and then now we need to know the reasoning. So let's go ahead and try to type that out. So for this, I will change the color, and we will match that up to green. Okay, because for the evidence, that was also green. So, and then we're going to start off with this sentence. I know this is true because, so let's go ahead and do that. I know this is true because if we multiply, maybe I should do a new line there. If we multiply k minus 9 times k plus 5, we get, and I'll handwrite this part. Bear with me, I'm going to use the different colored green. We get k squared minus 4k minus 45. And then if we multiply this by 2, we get, or I shouldn't say multiply, maybe I should say distribute. And if we distribute this by 2, maybe let me fix that. I should say, and if and then if we distribute this by 2, we get 2k squared minus 8k minus 45. And that should be our explanation using SIR. Oops. Just like that. Whoa, something happened here. Let me go back here. Change that to the blue. Change that to blue. Okay, so I tried my best to make everything color-coded for us to see. So hopefully you guys are able to tell and see what is what. So let me do this. Okay, that should be good. So everything in blue, that is our C part of SIR, so the claim. Everything in the pink, that is our evidence. And everything in the green, that is our reasoning. So now I know it's kind of hard to make sense of this, but maybe after reading, why does that keep happening? Okay, so let me do this. I'll just keep it green. 2k squared minus 8k minus 90. All right, we'll just leave it like that. All right, so that would be an appropriate SIR response. I know that took a while, but it is something that you guys do need to be able to write in. Okay, you do need to be able to write in this form. So again, let's just read over it one more time. I claim that 2k squared minus 8k minus 90 factors to 2 times k plus 5 times k minus 9. My evidence is that we can factor out a GCF of 2, leaving us with 2 times k squared minus 4k minus 45. Then we can set up and solve a diamond for negative 45 on top and negative 4 on the bottom, which works out. That should be out, not ours. Which works out to be negative 9 and 5. Now we can factor k squared minus 4k minus 45 to be k minus 9 times k plus 5. Then we put our GCF of 2 in front, giving us 2 times k minus 9 times k plus 5. I know this is true because if we multiply k minus 9 times k plus 5, we get k squared minus 4k minus 45. And if we distribute this by 2, we get 2k squared minus 8k minus 90. Okay. All right, so let's go ahead and move on to our next example. So problem number 3. Okay. So now in this problem, we're given this equation, y equals negative 2x squared minus 12x minus 5. We want to find the vertex and determine if it's a min or max, and then the axis of symmetry. If you guys have your reference sheets from the other day, okay, this will probably come in handy for these problems here. Let's recall, just by looking at this equation, let me see here. Just by looking at this equation, we should be able to find the way this opens, right? So which way does this quadratic open? Well, what's our a value? Well, a is -2, so that should tell us this opens down. And I forgot to mention on the last video, if a graph quadratic opens down, you can also call it a reflection. Okay, so down and reflection or reflected kind of mean the same thing. Now let's talk about how we find the axis of symmetry. Now if we use our reference sheet, this is in standard form. So the axis of symmetry in standard form is x equals -b divided by 2a. So that's exactly what we're going to do. X equals -b divided by 2a. And I'm not going to label a, b, and c because that is something you guys should be able to find. But recall that b itself is going to be whatever this value is. Okay, so this will be -12 divided by 2 times, and then our a value is -2. So -2 will go there. So let me just color match these. And then we can simplify. So x is equal to +12 over -4, which is equal to -3. So our axis of symmetry is x is equal to -3. Now, please be very careful with this. Don't just put -3 and say I'm done. You must put x equals -3. Okay, because if you just put -3, you will lose points. Okay, now we should already know that this graph opens down, which means this will be a max, but let's go ahead and find the vertex. So to find the vertex, we need to plug -3, x equals -3, back into our equation. So y is equal to -2x squared minus 12x minus 5. We're plugging in -3 in for x. So y is equal to -2 times -3 squared minus 12 times -3 minus 5. So we get y is equal to -2 times 9 plus 36 minus 5. Y is equal to -18 plus 36 minus 5. Y is equal to 18 minus 5, which is equal to 13. So our y value is 13. So our vertex is going to be, actually let me write out to the side here. Our vertex will be -3 and +13. So that's what we're going to write here, -3, 13. Okay, so that is how we do a problem like this. Okay, and again, remember this is a video, so you can always pause, rewind, and rewatch. Let's move on to problem number 4. Now, given the equation y equals -2 times 2x plus 1 times 2x minus 5, find the min or max and the vertex and the axis of symmetry. Now, this is in intercept form. Okay, so let's recall, how do we find the axis of symmetry in intercept form? And that's the midpoint value. So in order to do that, we need to make sure we use the zero product property. We're going to take every piece that has an x and set it equal to 0. So 2x plus 1, set that equal to 0, and 2x minus 5, set that equal to 0. We solve for x on each side. Here we get x is equal to -1/2, and here we get x is equal to 5/2. Now, to find the midpoint, we're going to use our formula. X is equal to x1 plus x2 divided by 2, which is -1/2 plus 5/2 divided by 2, which is 4/2 divided by 2, which is 2/2, which is 1. So our midpoint, or our axis of symmetry, is x is equal to 1. And again, we should be able to tell which way this graph opens based on our a value. And again, our a value here is a equals -2. So that means the graph opens down. And again, we can say this is reflected, or a reflection. Okay, I'll just say reflected here. Okay. Since we know this is reflected and it opens down, we know it's going to be a max. So let's find the vertex now. Okay, so to find the vertex, we're just going to plug in our x equals 1 point into our equation. So y is equal to -2 times 2 times 1 plus 1 times 2 times 1 minus 5. And again, all we did was we just plugged in 1 into x. So now we get y is equal to -2 times 2 times 1 is 2 plus 1. That gives us 3. 2 times 1 is 2 minus 5. That is -3. So then y is equal to negative 2 times 3 is negative 6 times negative 3 is positive 18. So our vertex is 1, comma 18. And that's what we're going to put right here, 1, comma 18. Okay. The x-intercepts, okay, we kind of already found those guys. That is these guys right here. Okay, so this will be negative 1/2, comma 0, and 5/2, comma 0. Okay, so we kind of talked about that the other day, so make sure you go back to that video. Now the new part for this problem is the y-intercept. So let's make a new section here, the y-intercept. This is the new part for this. Okay, to find the y-intercept, that is when x is equal to 0. Okay, so how the heck do we do that? Well, you just plug in 0 for x in your equation. So y is equal to negative 2 times 0 plus 1 times 2 times 0 minus 5. Okay, so all we did was we're taking 0 and we're plugging it in for x now. So y is equal to negative 2 times 0, 0 plus 1 is 1. 2 times 0 is 0, minus 5 is negative 5. So now we have negative 2 times 1, which is negative 2, times negative 5, which is positive 10. So our y-intercept is 0, comma 10. Okay, so that is problem 4. Okay, so again, at any point, you guys can always pause, rewind, and rewatch any of these sections and try to make sense of them. Okay, now let's move on to graphing. So in this problem, we are graphing standard form. So let's refresh our memories a little bit. We need to find the axis symmetry first. So that's x is equal to negative b divided by 2a. X is equal to negative 12 divided by 2 times 2. Okay, because let's recall b is 12 here, and a is 2. So that's how we get these values here. Okay, so 2 and 12. So then we get x is equal to negative 12 over 4, which is equal to negative 3. So x equals negative 3 is the axis of symmetry. And let's recall that goes in the middle of our graph or our table. Now, we want two smaller values, so negative 4 and negative 5, and then two larger values, negative 2, negative 1. Okay, and this is where you do need to do some work here. Okay, so we're going to plug in most of these values into our equation. Y is equal to 2x squared plus 12x plus 8. So let's go ahead and start off with negative 5. Okay, so we're going to plug negative 5 in. So y is equal to 2 times negative 5 squared plus 12 times negative 5 plus 8. Okay, so y is equal to 2 times 25 minus 60 plus 8. Y is equal to 50 minus 60 plus 8, which is equal to negative 10 plus 8, which is equal to negative 2. So I'm going to make a new column here. We're going to call it x comma y, which is going to be negative 5, negative 2. Now recall from the previous lessons, these two values should be the same. Okay. Now, be very careful. Don't be that lazy. You should still check this workout. Okay, you should still check it out to make sure you actually do get negative 2. I'll just give you a little bit of a shortcut, or I'll make it a little bit easier. It does work out to be negative 2, so you don't have to check, but you usually want to check, because if you get, let's say, I don't know, negative 8 here, then we made a mistake here and you need to check your work. Okay, but these two should always match up, so just an FYI. Now let's go ahead and plug in negative 4. So y is equal to 2 times negative 4 squared plus 12 times negative 4 plus 8. So y is equal to 2 times 16 minus 48 plus 8. Y is equal to 32 minus 48 plus 8. 32 minus 48 is negative 16 plus 8 is equal to negative 8. So our next ordered pair is negative 4, comma, negative 8. And again, remember, these two should be the same. Okay. Now, I'm going to say it's okay for now, but you should always still check the work when you plug in negative 2 to make sure you get negative 8. Okay. So now the last value, or the next value we need to plug in, is negative 3. So let's go ahead and plug that in. So y is equal to 2 times negative 3 squared plus 12 times negative 3 plus 8. So y is equal to 2 times 9 minus 36 plus 8. Y is equal to 18 minus 36 plus 8. 18 minus 36 is negative 18 plus 8, and that gives us negative 10. So our next ordered pair is negative 3, negative 10. And then this ordered pair, negative 2, negative 8, and negative 1, negative 2. So let's go ahead and graph. So our first point is negative 5, negative 2, followed by negative 4, negative 8, followed by negative 3, negative 10, followed by negative 2, negative 8, and negative 1, negative 2. Okay, so then now we can connect our points just like that. Let's make that look a little bit better. There we go. Okay, and then now let's fill out all this good information here. So A, we know is 2, so that tells us the graph opens up. Why? Because A is positive. Okay, and I'll just put that for short. Okay, what shape is this? Now you really need to understand the shape, because I was looking at some of your assignments and we still do not understand the shape. Okay, so it's based on your A value. So in this case, A is 2, so we take the absolute value of 2. Okay, so absolute value of 2 is equal to 2. So that means the absolute value of A is greater than 1, which means this is a vertical stretch. Or if you put stretch here, that I will accept that. Some of us were just putting the word vertical. Well, this is also called vertical, but vertical compressed. So be very precise. If you say stretched or compressed, that's perfectly fine. Okay, now why is this stretch? You need to say because the absolute value of A is greater than 1. Some of us were not putting that. So make sure you are very precise in your reasoning. Okay, the axis of symmetry, that is x is equal to negative 3. Our vertex is negative 3, negative 10. The graph opens up, so this is going to be a min. Okay, so we'll just say min here. Or if you want to say the lowest y value, you can say y is equal to negative 10. That's also fine, because I think some of us were doing that. That's okay. And then the domain is always the same, negative infinity, comma infinity. Okay, so if we reference our sheet, the domain is always going to be negative infinity to infinity. Now the range, some of us are still making mistakes here, so let's go over the range very carefully. Okay, if the graph opens up, we start with the lowest y value. Okay, let me change that here. Okay, we start with the lowest y value with a square bracket. Well, we have the lowest, or it is opening up, so this is my lowest y value, which is going to be negative 10. So we're going to start with a square bracket, negative 10, and it goes up to infinity with a parenthesis, which is what it says here. Okay, so that's the range. Now the end behaviors. Okay, for every graph, every quadratic that opens up, you always have the same end behaviors. Okay, now I think some of us were getting a little mixed up. Your first two values on the end behaviors should always be infinity and negative infinity, just like that. Okay, these two should never be the same. They will always be different. Okay, now depending on which way your graph opens will determine how these two will look. Okay, since our graph opens up, okay, let's just talk about this one more time. So as we go forever on the x-axis, that way we approach infinity, which is represented by this. So I want to know, what is this side of the graph doing? What is the right side of the graph doing? Well, this is going up forever. So up forever is infinity. Okay. Now, same idea on the left side. As we go to the left forever, that is negative infinity, which represents this. So I want to know, what is the left side of the graph doing? Well, this is going up forever, which implies infinity. So y approaches infinity. Okay, so let's really try to make sense of our end behaviors, because they are super important and will be important for the next, for later down the line. Okay, so this was our refresher on how to graph standard form. Let's move on to our next example. Now, this example is intercept form. Okay, so let's recall, to graph intercept form, we need to first use the zero product property to solve for all the x's. So we're going to take this guy and this guy, set them equal to 0. So x plus 6 is equal to 0. X plus 4 is equal to 0. X equals negative 6. X equals negative 4. Now we can find the midpoint using our formula. X is equal to x1 plus x2 divided by 2. which is negative 6, plus negative 4 divided by 2, which gives us negative 10 divided by 2, which gives us negative 5. So negative 5 is the midpoint, and that goes in the middle. Okay. Now we want two smaller numbers, so negative 6, negative 7, and two larger numbers, negative 4, negative 3. But notice we already have two of these values. We have negative 6 right here, and we have negative 4 right here. Okay, so automatically those y values will be 0 and 0. And it does follow the pattern here. These two are the same, so this is true. So now this just lessens our work a little bit. So now we only need to plug in negative 7, negative 5, and negative 3. So let's go ahead and do that. So y is equal to negative 2 times x plus 6 times x plus 4. So let's plug in negative 7. Whoops. So y is equal to negative 2 times negative 7 plus 6, negative 7 plus 4. So y is equal to negative 2 times negative 1 times negative 3. Y is equal to negative 6. Okay, so our first ordered pair is negative 7, negative 6. And remember, according to our pattern, this should also be negative 6, okay? But this time, last time I said you need to check, right? I told you to check, but this time we are actually going to check, okay, just to verify. So our next ordered pair will be negative 6, comma 0, okay? Now we're going to plug in 5, or negative 5. So we have y is equal to negative 2 times negative 5 plus 6, negative 5 plus 4. Y is equal to negative 2 times 1 times negative 1. Y is equal to positive 2. So our next ordered pair is negative 5, comma 2. Our next ordered pair is negative 4, comma 0. Okay. And then now we are actually going to check this last one. I know in the last graph I said you don't need to check, but just for good practice, we are going to check this one. So y is equal to negative 2 times negative 3 plus 6, negative 3 plus 4. Okay, so y is equal to negative 2 times positive 3 times times 1. Oops, I forgot that should be negative 6. We get y is equal to negative 6. So yeah, these do end up working out. Okay, so now we can go ahead and graph. So negative 7, negative 6 is right here. Negative 6, 0 is right there. Negative 5, 2 is right there. Negative 4, 0 is there. And negative 3, negative 6 is right here. So now we can connect our points. Just like that. And now we can fill out all the fun stuff. So here A is negative 2. Okay, that tells us the graph opens down. Why? Because A is negative this time. Okay. The shape, so let's double check that. Okay, let's go back to the shape up here. So be very careful here. So we take the absolute value of negative 2. Whoa, wait, okay. Now we're going to take the absolute value of negative 2, which is still positive 2. It is still going to be a vertical stretch, okay? So we're going to go ahead and write down stretch. Okay, why? Because the absolute value of A is greater than 1. The axis symmetry here, x is equal to negative 5. Our vertex is negative 5, comma 2. This is going to be a max, so I'll write down max, or if you want to write down y equals 2, that will also be fine. Our x-intercepts are where the graph intersects the x-axis. So if this is our graph, and this is the x-axis, they intersect at these 2 points. They intersect here, and they intersect there. So those will be negative 6, comma 0, and negative 4, comma 0. Okay, our domain is always the same, negative infinity, comma infinity. The range, okay, let's talk about the range very carefully. This time our graph opens down. Okay, this time our graph opens down. So we start with parenthesis, negative infinity. So parenthesis, negative infinity. And then we go up to the highest y value with a square bracket. So on my graph, this is my highest point. This is my highest y value. So we're going to go ahead and go 2 with a square bracket. Okay. And every detail counts, guys. Every parenthesis, every bracket, the order is super important. So make sure you guys are paying very close attention to the order, because I think on some of the assignments, some of you guys did not have the right order. Okay. Now, again, let's talk about the end behaviors. Just as I mentioned for the last graph, the first one will be infinity. The bottom one will be negative infinity. That will always be the case. Okay. And then you can also reference your sheet here, right? This time our graph opens down. Okay. So as you guys can see here, right, the top one is infinity, the bottom one is negative infinity, just how we had it here, okay? So now we just need to fill in those guys, okay? And it's always going to be just like that. So y approaches negative infinity, y approaches negative infinity, okay? But let's also talk about it a little bit, okay? I want to make sure we absolutely understand what's going on here. So as we go on the x-axis to the right forever, that is, we are heading towards infinity. Then I want to, which represents this piece. So now I want to know what's happening on the right side of the graph. Well, hey, that's going down forever, which is negative infinity, which represents that side, okay? Now, as we go to the left forever, okay, that is negative infinity, which represents this, right? And remember, that's on the x-axis. So I want to know what's happening on the left side of the graph. Well, that is also going down forever, which represents negative infinity, which is this side of the graph, okay? So that was our quick refresher on graphing standard form and intercept form. This will be your assignment here, okay? Now notice on number 6, there is no table here. You guys need to make your own table. So I will say, make your own table, okay? And that is about it.